Hello and welcome back to my Blind 75 Python solution series. Today we are going to be taking a closer look at LeetCode question 53, also known as maximum subarray. This is an easy level question, and today's solution will be in O of n time and O of 1 space. So let's take a look at this problem. Given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. And a subarray is a contiguous part of an array. And so what it means when it says contiguous is that we cannot skip over pieces in the array. To equal a sum, you have to start at one area of the subarray and then it has to go subsequently through. So you cannot just skip around in the array. So we take a look at this example. We have an input with our nums array equaling this array right here. And say when we look at this, so our answer when we look at this array, the sum is going to come out to 6. That's going to be our maximum sum. And as you can see, this array, which is what got the 6, is in order, which is what contiguous means. We'll be solving this problem using Cadane's algorithm, which is simply just iterative dynamic programming. And to explain a little bit about what dynamic programming is, simply put, it's when you break a problem into a collection of subproblems which all have the same exact criteria. And then you want to solve each of these subproblems, store the solution, and then return the solution you're looking for, such as a maximum or minimum value of the subsequent subproblems. So the maximum subarray problem is a perfect example of when you would use dynamic programming. So before we're going to solve this problem, please take the time now to subscribe to my channel and like this video. Really helps me out and I'd really appreciate it. All right, so now that you've done those things, let's move this over to the problem breakdown. So right here, as you can see, I've already added this nums array from the example, and we're also going to create two variables. So one is going to be cursum and one is going to be the max sum. And then the steps that we're going to be looking at is we're going to have 3 steps, and then step 2 is going to have a couple different steps as well. So for our step 1, we're going to make our initial variables equal to the first value in the array are going to be -2. We're just going to skip over in our for loop and we're just going to put this I value, and I'll write it over right here, at the first index value. And then what we're going to do next is we're going to just loop through the array, and then we're going to find the max of the current sum plus our current index value versus our current index value. So cursum plus current index value versus current index value. As we move along in our array and we look through the values, we're going to be using this current sum right here, this I value, and we're going to be comparing it versus that plus what our current sum value is. After that, we're going to be finding the max of cursum and maxsum. So we're just going to compare those two. And then of course at the end, we're just going to return the max sum. So let's go through the problem step by step. So in our first loop, what we're going to do is we're going to look at our cursum right now, which is -2. So it's going to be -2 minus our current index value, which is going to be -1, and that is going to be equal to 3. We're then going to compare 3 to the current index value. So -3 versus -1. And we're going to see which one is the max of those, which is just going to be -1. So this value, our current sum, is going to be -1. And then we're going to compare that -1 value to -2. And we're going to see which one's bigger. We already know -1 is bigger than -2. So we can put down here, -1, -1. Next, we're going to go to the second loop and we're going to compare. So we're going to move this I value over right there. We're going to compare the two again. And this time we're going to do -1 minus that value, but it'd be plus, but it's a negative. So it's going to be minus. It's going to be equal to -4. Then we're going to compare that to that -3, which is our index value right now. And which one is bigger? It's going to be the -3. So this becomes our current sum is -3. Then after that, all we're going to do is compare -1 to -3, and we know -1 is bigger, so we're just going to keep that value. So this becomes current sum is -3, and max sum is going to be -1. So we're going to do the third loop now, and we're going to move our I over, and we're going to take -3 plus 4, which is going to equal 1, and this is going to be versus this index value right here, which is going to be 4. So the current sum is going to be 4. And then so we're going to take 4 versus -1. That's going to be 4. And so our current sum and our max sum is 4. So for the fourth loop, we're going to move this I over again. And same deal, 4 minus 1 equals 3 versus -1. 3 is obviously bigger, so we're going to keep 3. And then we're going to compare 4 and 3. And 4 is, of course, bigger, so we're going to leave that value there. So we're going to go 3 and 4. On our fifth loop, we're going to move the I value over again to the 2. And then we're going to do 3 plus 2 equals 5. 5 versus 2, and 5 is greater. So we're going to save 5. 4 versus 5. 5 is greater, so 5 is our current max sum. And we're going to save this as 5. In our sixth loop, we're going to move the I over once again. We're going to add 1 to 5. So 5 plus 1 equals 6. 6 versus 1. Of course, 6 is greater, so our current sum is 6. And then 6 and 5, what's the max of that? We know it's 6. So 6 is our current max sum. So 2 more loop throughs to get to the end of the array. Of course, we know that's our answer, but I'll just finish out the sequence. 6 minus 5 equals 1 versus -5. Which one's bigger? It's going to be the 1. And then 6 versus 1. What's bigger? It's going to be 6. Current sum is 1. Max sum is 6. And then for our last loop through, we're going to move that I value again over to the 4. We're going to take 1 plus 4 equals 5. 5 versus 4. And the reason that we do that is because we have to see, as it says in the problem, it has to be contiguous. So the reason that we keep comparing those two values is to see if that next value is larger and if that's bigger than what we already have as our current sum. If that is, then we need to just start over. That's all it looks for. That's why we do the comparison there. So 5 versus 4, we know that 5 is bigger, so we keep it. And then 6 versus 5, what's bigger? We know 6 is bigger, so it's 5 and 6. And 6, because we're done looping through the array, is our maximum sum, and we are done. All right, so let's code up this problem. So let's create the function def max sub array, and inside of it we're going to put our nums array. And then what we're going to do first is we're going to create our 2 variables to keep track of our max and current sum, and then we're going to set both those values equal to the first value in the array. So we're going to go current sum, and we're just going to make them equal to each other right now because they're equal to the first value in that array. And that just saves us a little bit of time in our loop because we already know that we're going to need that value in there. Next, what we're going to want to do is just loop through the array. So we're going to go for I in nums 1. So we're going to start at the first index, and this is just another way that you can iterate through an array. This, of course, you can change it out and do the whole range len nums, but because we're using this, we're already starting here, we do not need to do that, so we can actually just use this. This is just a little bit more Pythonic, and it's just another way to do this. So next, we only have 3 more lines, unbelievably, right? So that we have to create. Next is going to be our current sum is going to be the max of our current sum plus the current value I. So like I said before, and I explained before, when we did the problem breakdown, this is what this is going to look like in code version. So the max of our current sum plus the current value I versus I. And let's just actually write this out, and then I'll explain it a little bit more so that makes sense. And it's just a really simple line of code right here, plus I, and then versus I. So as I said before, what we do here is we just look to keep track if the current sum we've been working on is better or worse than the current value in the array. And then we're just going to decide if adding that number or starting over and making that number our current sum is better. So if it's a bigger number, then you want to make that the current sum, because our last sum that we're using is smaller. And that's the whole point of having a contiguous subarray. For our next line, what we're gonna do is we're gonna just find the max sum, and that's just gonna be the max of our current max sum versus the current sum. So if our current sum is bigger than the max sum, we're gonna make that our max sum. And then all we're gonna do last is just return max sum. and then you're done. That's it. So all we're gonna do now is just check this problem. So I just created this print statement, which is gonna run our function. Oops, and I just have to make this into an array, my bad. And now we got it. We got 6 right there. So that is our answer. I hope that helped you out. If it did, please like and subscribe to my channel to get more on this Blind 75 series. It really helps me out and I'd really appreciate it. Until next time, I hope you have a great rest of your day. I hope you get out there and you just keep on coding. You got this. See you next time.